On behalf of Flightline Geographics in Esri, welcome to Drones Over Ghost Ranch. My name is Kurt Schwope, and I'm the Business Development Manager for Imagery at Esri. And as part of my job, I get to work with our partners who have awesome applications of our technology. And one of the ones that I saw this past year that I really appreciated was the work that Flightline Geographics was doing with drones and ArcGIS and combining them together to make an amazing solution that can solve so many problems for microgeographies around the country that need high-resolution imagery and 3D products. And so I was talking to Devin and said, why don't we put on a webinar and show some of the people the great work that you're doing and give them an idea of what this technology is capable of doing. And so I'm very happy to present Devin and Flightline Geographics, and they're a fantastic partner of Esri, and we look forward to presenting to you the work that he's done, and we hope you really appreciate it. So right now I'd like to turn it over to Devin, and by the way, there is an ability to ask questions throughout the presentation down there in the webinar dialogue, so please, if you have any questions on what you'd like to see, just type it in there and we'll try to answer them towards the end of the webinar itself. So without further ado, I'm going to turn it over to Devin, and let's take a look at Drones Over Ghost Ranch.
Hey, thanks, Kurt, and happy Halloween, everybody. I see here, looking at the attendee registrations, we've got attendees signed up from several states around the country, plus overseas. We've got our friends next door in Canada and Mexico, also as far away as Russia and New Zealand. Hello down there. So happy Halloween. The quote that you see up here on the screen right now, we got this quote a couple of years ago for a press release with Texas A&M University's FAA test site, and it's from Jack Dangerman, and it really sums up what it is we're doing, and for some of our customers, what we're equipping them to do. We come to this as being long-time frustrated GIS users, looking for better content, either fresher data, higher resolutions, or 3D content. And drones really changed the game for us. The ability to capture, process, and deliver in near real time is a game changer. And in some cases, like disaster response, that can mean overnight. In other situations where time's not really a factor, maybe a couple of days. But that's so much better than what we've been working with in the past. So we've set up a company that's both a capture as a service, GIS focused, and also we do train and equip some of our customers that want to establish their own in-house capability as an international distributor for the technologies that we use. And you're going to see some of those here. Okay, so Drones Over Ghost Ranch. Just a little bit of background on Ghost Ranch. It is the original Dude Ranch in Abiquiu, New Mexico, and it's over 21,000 acres. And you've seen it before because they filmed lots of major motion pictures there, including Indiana Jones, Cowboys and Aliens, No Country for Old Men. And since it's the original Dude Ranch, they filmed City Slickers out there as well because it's got some fantastic scenery, very rugged, very challenging, especially for drone work. It also happens to be the longtime home of artist Georgia O'Keeffe, and she used it as a home base for many years and painted all these fantastic artworks showing the southwestern scenery. So why did we go there? The challenge on this project was that in 2015, the ranch had a freak downburst thunderstorm in a box canyon, and a box canyon is like a funnel, that damaged the ranch facilities there at Ghost Ranch. A pottery shop, a metal shop, and some other facilities were all damaged when the waterway came out of its banks. So the purpose of this project is actually a hydrology study, and to do that study, the engineers needed high-definition 3D terrain and imagery, high-definition imagery base map for GIS. And it had to be affordable. They were working on a fixed budget for the project. This is a nonprofit that owns and operates Ghost Ranch. And oh, by the way, we need it fast. And that was quite a challenge. So the client has a need for high definition GIS content, better data, within budget, and fast. Those three things normally don't go together. But UAS is actually a game changer, and it was possible. What they needed was engineering grade GIS data, meaning controlled with survey grade ground control. And what do we mean by that? Survey grade ground control in this case meant that the coordinates needed to be within plus or minus half an inch, X, Y, and Z. And that Z is really difficult to get. So it needed survey grade ground control. Also, the imagery, we needed to use the highest quality cameras possible in order to produce the 3D HD imagery that they were looking for. And oh, by the way, everything needed to be GIS ready. So, Flightline Geographics, just a little bit about our background. We had the experience to deliver on this one because we've got over 30 years in GIS, and 10 of those years specializing in the use of UAS. And you might wonder, well, how did you get started so early? Because the FAA didn't have an authorization program until 2015. Well, we worked on Department of Defense, government, and university UAS projects where they could get the permits. And so we operated on their behalf, and that gave us a nice head start on the technology 10 years ago now. We actually operate a mil-spec GIS-centric platform that was ideal for this job, as you're going to see here in a moment. You know, why would GIS matter? Well, it matters in this kind of terrain that we were working in. Also, the key to all of this, and if you take away nothing more, realize this. It's all about the camera. Drones are cool. There's all kinds and flavors and shapes and sizes of drones out there, but it really comes down to the quality of the camera and the lens to produce high quality data. And if you're skimping on the camera and the lens, then you're cutting yourself short on data. So we chose a mil-spec platform that can carry the larger cameras that we needed to use on the project. All right, so let's go through the project setup and you'll understand a little bit about the challenges. It was pretty interesting. We actually plan a project in GIS before we ever leave. We plan and we rehearse and we flight simulate. And what you're looking at here on the screen is ArcGIS and the digital elevation model for the area of Ghost Ranch that we were going to capture. We're going to capture about 1,000 acres of the 21,000 for this drainage study. And so what we did is we bring in the DEM, and also the green boundary shows the area that they want captured. And the red hatched circles in ArcGIS are representing places that we need to look out for, because these are buttes and mesas that stick up above the surrounding terrain. And obviously we don't want to fly into those. So we mark those on the map as well. And then you see the green dots that are numbered. Those are the ground control points. More on the ground control in a moment. But we had to spread out the survey grade ground control throughout the project and along the drainage so that we had proper control over the entire project. Okay, so we use the GIS for a number of things: planning the site layout, planning the ground control, finding our obstacles to look out for, but we also plan it for airspace approval, because the FAA does limit some of the locations where you can go. And one of the first things we do is bring up an FAA aviation chart on top of the GIS and check and make sure that we're in an okay location to fly. Some locations are absolutely no-fly zones. Others can be flown with special permission or a waiver. And then there are some areas in the country where it's wide open, no problem. Well, one of the first questions we need to answer on a project is this even doable? So we use the GIS to analyze that question up front. And then obviously we can look at it for size and shape and pricing and all of that. Terrain avoidance is very important. Don't want to crash your expensive drone. And we have the ability to actually run the flight simulator here and simulate the mission just like the astronauts before you go. And that way you know how many flight lines is it going to take, about how many photographs are you going to capture, and so on and so on. So any time spent in this planning stage is time well spent. All right, a little bit more about the platform. Why mil-spec UAS? Well, several reasons. It's reliable, it's robust, it's redundant, has redundant systems, And it has a lot of safety features that the FAA likes and we like, such as you see here the parachute landing mode. That means we don't need a nice grassy soccer field to land the drone. We can land in some pretty rugged terrain with no problem, and confined spaces as well. Don't need a long runway. That parachute's also a safety feature. The autopilot is always watching and monitoring all the systems. If anything at all goes wrong, you bank too hard, you go into a dive, you get going too fast, it says something's wrong here, and it pops the parachute. So that safety feature is very important to us, and fortunately we haven't used it in safety mode, but we use it every time in landing mode, so we like it a lot. And probably the most important factor, and the thing that really got us interested in this particular technology, which by the way was introduced in 2012 at the Esri user conference in San Diego, right up on stage. John Calkins introduced this technology, and at that time, 5 years ago, John said, this is the way we're going to be capturing data for GIS. And here we are. Anyway, the thing that really excited me about this technology when we first saw it is it actually uses ArcGIS to fly the plane. And what you see here on the screen is the flight control window, and all of the various controls and gauges wrapped around the map. That's Esri runtime environment. It's been customized with all the controls and readouts, but what's important here is it shows any GIS you want as your background map plus your project area, and it's right there on the screen along with your plane's location. And to fly the plane, we actually just take our mouse and click where we want it to go, and it goes there. The autopilot does the flying. Now, we can pre-program a flight plan and fly a grid. That's not a problem. But in a situation like this, where you're trying to make sure and avoid certain things sticking up that could ruin your day, the manual flight planning and flight operation is the way to go. Plus, another thing that's really cool about the GIS-centric way of capturing is that darkened area over the project study area. Those are individual photo frames of the imagery as it's being taken. So we see the imagery or the project area being covered up, and we have a high degree of overlap here. And we know before we ever land the plane that we didn't miss any spots. This is like mowing the grass, back and forth with some overlap. And you want to make sure not to miss anything because it's a long ride from New Mexico to Texas. And you don't want to have to go back, just because you missed a couple of spots. And the GIS-centric control system here ensures that we've covered up the project area, we've got all of our areas of concern mapped out, and we know before we ever land that it was a successful capture. Now, I mentioned that the camera is the whole point of this. Yes, the drone is very cool, but this is what gets the data. And so you really don't want to skimp on the camera. Quality photogrammetry requires quality cameras. And the drone has to be able to carry that camera. So that's how you pick your drone. So we're using quality digital SLR cameras with the very best lenses from both Zeiss and Voigtlander. We're shooting cameras, depending on which camera we pick, anywhere from 24 to 42 megapixels on the imagery. And in this case, with the fixed wing bird, all of our pictures are taken looking straight down. They're nadir, or looking straight down. That's for mapping purposes. All right, ground control points. Well, actually, if we don't do ground control, then you're going to have a hard time placing the data in the right place on the planet. Now, the drone can do it with its onboard GPS fairly well, but for an engineering study like this, that's not good enough. Engineering grade results require survey grade ground control. So we selected those GCP or ground control point locations in GIS before the trip. Then when we went out to the field, we actually used Esri's collector. We uploaded them to ArcGIS Online, and we used the collector app to help us find those locations in the real world and go put down our flags or our panels. And as you see there, Drew's about to place a panel, and the surveyor is going to come along behind and mark the locations of the center of those panels in XYZ survey grade coordinates. This is a very important part of the project. We did this the morning before we were ready to fly. We usually wait for the sun to get up high in the sky between 11 and 1 o'clock. So you have the whole morning to set up the ground control and get things ready and pre-flight before you fly. On GIS capture day, we set out the ground control in the morning. It takes us about 15-20 minutes to run through all of our setup and pre-flight checks, and then it's time to fly. And in this case, we only needed to capture 1,000 acres, so it was a single 60-minute flight, actually a little bit under 60 minutes, and we used 80% overlap, which is a high degree of overlap, but that's what's required for the 3D. And when we're ready to go, that's a launch. We don't have to carry any kind of catapult technology or anything like that. It's all hand launched. The system's made out of carbon fiber and Kevlar, so it's very lightweight, around 10 pounds or so with the camera. So you just throw it in the air and don't have to worry about catapults and another piece of equipment that might break or whatever. So once we've flown and captured, we're ready for the GIS-ready deliverables. So what did they want? We use a combination of tools to provide all the various deliverables that were required. Drone to Map is one tool in our toolbox. We have others as well that do special things. High resolution image base map for GIS. In this case, because the flight altitude that we flew, the resolution was 1.25-inch resolution, which is pretty good. But what's more important was they needed the 3D terrain. So we produced a 3D LIAS point cloud. LIAS is the same file format as LiDAR. It's produced differently, but it's the same kind of data. And then we produced a digital terrain model, a true DEM, by stripping off the vegetation, structures, and other things that would clutter up the data and give you false elevation readings. So all of that to produce elevation contours for the project at 12-inch contour interval. And there you see on the screen what 12-inch contours at some of these locations look like. They can get pretty busy. The last deliverable that we produced was something you may or may not be familiar with yet, but you will be. It's called an I3S. And an I3S is Esri's 3D model format, and you're going to see what we would do with that here in just a few minutes. But it takes the imagery, the 3D information, and creates an actual 3D model of the world that you're looking at that can be navigated and looked at from different angles. It's like having your own private version of Google Earth, for example. So here's some of the results. And I want to say a few words about this photograph. The image portion on the right is one of those buttes that's sticking up. We had to plan the flight so that we were safely above those features, and we're about 300 feet above this butte on the right side, the cliff. And we're about 1,000 feet above the stream on the left side of the screen. And this is where the quality of the cameras and the lenses really comes into play big time. While we're flying at a safe altitude, we're capturing everything we want to see in focus. That is very, very key, because the potential exists that, you know, the image on the right's in focus, the image on the left is out of focus. Well, the lenses and the settings and the techniques that we use, everything here on the screen is in focus, even though we've got a huge 800-foot difference between the high ground on the right and the stream on the left. All right, I mentioned the 3D model. This is a GIS visualization of the 3D model that was created using imagery. Now keep in mind, all the photographs used to produce this imagery were taken looking straight down. There are no oblique or angled shots involved here. These are all straight down images that produce this 3D model, and you can manipulate it, turn it, zoom it, measure things, including volumes. You can measure volumes. There's a few more looks at that. The stream that caused the flash flood is the one going through the middle of the screen there, and right now it's just a trickle. But during the flood that damaged the ranch, it was a 20-foot wall of water that came down there, because this box canyon is literally like a funnel, and all the rain fell on the top of the funnel. By the way, the 3D models that we're looking at here, they're not just eye candy. Things are metric or measurable on the screen. And part of what we deliver to the customer, because they may or may not have any 3D visualization or viewing tools, part of what we deliver to the customer is a free viewer so that they can actually take the data set and the viewer and explore it on their own, show it to folks at work, show it to the boss, measure things, and do things without engaging a GIS person. So it's a great opportunity to spread out the data within the organization. Here's another scene showing the 3D structures, trees, terrain, and even the vehicles are shown in high detail. And again, these were all straight down photographs. We're just looking at it in perspective view here. This one I like a lot. This is toward the highway, or the southern end of the project. It's carved out quite a little canyon there, and whenever it flash floods, it almost fills that canyon. So that's an idea of how much flooding can happen in these box canyons. And what's really interesting to me is, even though the pictures were all taken straight down, we got data underneath that bridge on the highway. So we're seeing under the bridge, and there's data there. It's not just made up information. Okay, so once we collected all this imagery and produced the basic deliverables, we turned that over to Keystone Restoration Ecology, and what they did is they did the hydro study for the project, because they're trying to find ways to mitigate the danger of some of these flash floods, at least the property, so they can protect some of that property. So they took the 1-inch resolution digital elevation model data and took it into a hydro package that they use, and it's GIS based, and they produced what we're going to see right now. This is a false color DEM showing a 20-foot wall of water traveling through the canyon, and as it oozes around and flows over some of the high ground, you can see exactly what happens with this 20-foot simulated wall of water. And here it is over the imagery instead of the false color DEM. So this was actually the end point for why we did this. Collect high quality data for GIS and for the engineering study, turn it over to the engineers. They're happy because it's high resolution, survey grade, meets their specifications, and quite frankly, they had no other way to generate this data affordably and certainly within the time frame that they had to work with. Go to the next slide. Okay, so the 3D models that were produced also can be looked at in ArcGIS Pro. If you've been out there using ArcGIS Pro, you know that it can deal with 3D data, and here is the view down the box canyon in ArcGIS Pro where the stream traveled. There's our cliff face on the right we were looking at a minute ago. Imagine 2 or 3 inches of rain falling all in this area up on the high end of the canyon. It's got no place else to go but down the stream, and that took it through the ranch facilities you see down toward the bottom of the screen. Another product from Esri that can also deal with the 3D models that we produce is ArcGIS Earth. A good friend of mine that worked with me on the Deepwater Horizon named Darren is a product manager for ArcGIS Earth, and we actually brought it into this product and can view it and manipulate it. It's very cool. It's a great way to share content like this with others in your organization or your customers. So don't forget about ArcGIS Earth, because it's an excellent 3D viewing tool for data like we're producing here. All right, kind of beginning to wrap it up, and then we're going to take questions toward the end. You may have heard of Gartner Research. They produce something called the hype cycle, and this applies to a lot of different technologies, cell phones, fax machines, GPS, what have you. In the very beginning of a new technology, there's a lot of hype. In fact, it's often oversold, the capabilities of a new technology. And this has happened with drones. You have this giant peak of inflated expectations on the left side. We call it the cliffs of insanity. And everything's all hyped up and pumped up, and then people get out there and they find out, oh, it doesn't fly very long, and oh, my pictures aren't that great, and oh, it takes a lot of processing power to process, and you have this disillusionment, the trough of disillusionment. And at the very bottom of the trough of disillusionment is the pit of despair. The pit of despair is when you just totally give up, you've overpromised to the boss or to your customers, and now you got to find a way to do the project. We know that this curve is in operation with the drone technology, quite frankly, because the United States is a few years behind other countries on this, including Canada, New Zealand, Australia, even Mexico is further along in some ways on drone technology because they didn't have as restrictive regulations as we had here for years. So they've actually been through this pain cycle already and have come out the other end with some things that work. And we were fortunate enough to be able to hop on the train over there on the right side at the paradise of productivity. And it's not that we're smarter than anybody else, we just got to jump on later. And I'm a big believer in not reinventing the wheel or reinventing the mistakes. So right now in the US, there is a bit of an overhype on drone technology, and people need to figure out what they're good for, what they're not good for, what are the limitations, and what should proper expectations be. And we do help others. So there's an article in the spring 2016 Esri Arc User magazine on page 30. Actually, I've got two articles in this issue. Page 18 describes how we use the combination of ArcGIS Online and Collector as an operations dashboard during a disaster response, along with drone imagery. And then on page 30, there's an article, Getting Started with UAS, for you do-it-yourselfers out there. But if you need some help, we can help organizations get started with drones, fixed wing systems. We also operate some pro rotor systems. And what is a pro rotor system to us is, can it carry the cameras we want to carry? And we also provide flight operations teams. Right now I've got flight teams operating in Minnesota and Colorado on a 2,000-mile electric transmission project. And so we provide trained operators, experienced operators for folks that need a little help along the way. And sometimes you're collecting so much data you just flat can't get it processed. We can actually help out with processing as well because we've built an enterprise class processing platform here and can help you with processing on demand. I want to remind you at the end of the survey, please take a few moments. There's just a short 6-question survey. We'd like to get a little market research and cut through the hype, get your opinion. We value your opinion on these topics. So it's just 6 questions if you don't mind. And we'd be happy to keep you private on that. And there is my contact information, which I'll leave up here on the screen for a few minutes while we're kind of wrapping it up with some questions. So go ahead and type in any questions that you may have, and we'll get going with that. I've got a few that have come in here. Let's see. Okay, here's a good one. Everyone wants to know, how long can the drone fly with those heavy digital SLR cameras? That's a good question. We're flying with a fixed wing system. We're flying between 60 and 90 minutes right now with the heavy cameras. So that's what we can do with the fixed wing. Now, obviously, the rotors don't fly quite as long with that same camera. Somewhere between 25-30 minutes with the pro rotors. And then you have to do the math to figure out how much area you can cover in either 60 to 90 minutes or 30 minutes. Okay, here's the second question, the follow-up question. How many acres can be captured in a day? Sometimes we measure it in acres and sometimes we measure it in miles. Typically, we're capturing with good sunlight, because we're working between 10 and 2 midday sun with reduced shadows. We're capturing between 4,000 and 5,000 acres per day. 4,000 and 5,000 acres. That's with the fixed wing. That equates to about roughly 8 square miles. And some of the larger projects that we've worked on are things like wind farm sites that are under construction or being planned, solar sites that are being planned. They need that 3D data, and they're typically large areas. One of the wind farms that we've been looking at recently is over 100,000 acres. So you really need some duration to be able to do that. And by the way, I mean, there is a logical point where it just makes sense to go with a manned capture instead of drones. It gets too large, you're just making too many flights. And at some point, it makes more sense to get a manned airplane, and we do that too. Okay, another question on the FAA. Good question here on the FAA. What sort of FAA authorizations are required? Okay, our company has a Part 333 exemption, and that's what companies got beginning in 2015. for commercial operations. And then the individual pilots obtain something called a Part 107 authorization, where you actually have to study and take a test. It's not terribly hard, but it proves that you know the rules and can read an aviation map and read a weather statement, things like that. So those are the authorizations that are required to do anything other than for fun. If you're just out there for fun, you don't need any kind of authorizations. You got to check through airspace, make sure it's good. But if you're making money or doing this for your company or doing this for professional purposes, then you've got to have at least the Part 107. In our case, we got the 333, which actually allows us to apply for some more advanced topics. And insurance, don't forget about insurance. No one's asked that one yet, but insurance is very important too. Pipeline companies, electric companies, and so on, they want us to carry up to $6 million worth of liability insurance that specifies UAS. It can't just be any old insurance. It has to specify drones. So insurance is also important. Okay, getting some pretty good questions in here. What is the typical resolution at the maximum legal altitude that you can get? Okay, well, the maximum legal altitude is 400 feet above ground level, or AGL, and sometimes you can get permission to go a little higher, but let's just work with that 400 feet. It depends on the camera and the lens, and if we're needing to fly a long time and resolution is not really our primary concern, we might put a lighter weight camera and fly a little bit longer. But depending on the camera and the lens combination, we're getting anywhere between 1/2 inch and 1.25 inch resolution with our current cameras and lens combinations. So it can be as good as 1/2 inch if you need it. It can be 1.25 inch at the maximum altitude of 400 feet if that's good for you. Okay. What about aerial RTK or PPK GPS? Can it eliminate the need for that ground control? It's a question we get all the time. RTK, real-time kinematic, or PPK, post-process kinematic, is a way of improving the onboard GPS accuracy of the drone itself. And it can reduce, but not completely eliminate, the need for ground control. I would never say that it can completely eliminate. You still may use a few points just to keep it under control, but what this means is you can greatly reduce the number of panels you put out. Instead of 12, maybe you put out 4 or 5, and it keeps everything under control very nicely. And sometimes an area can be hard to get around, like maybe a marsh or a swamp. We've done work in Louisiana, crawfish farms, where it's difficult to get out there and put a panel, if not impossible. So the better GPS on board the drone can help, but not completely eliminate the need for ground control. Okay, another one here. How would this work for long linear features like pipelines and electric transmission lines? Well, we've done a number of these. We've done some pipelines in the 30 to 50 mile long category, no problem. And right now, as I mentioned a while ago, our flight teams are supporting a 2,000 mile electric transmission line project in the Midwest and Colorado. The biggest challenge is not for the drone. The biggest challenge is maintaining visual line of sight that's required by the FAA. So we use lots of what they call visual observers, or VOs, and we have obtained occasional beyond visual line of sight permission for things like disaster response. One of the articles I referred to a while ago in the ArcUser from spring of 2016 covers how we were able to obtain an emergency certificate of authorization from the FAA to do beyond visual line of sight to capture a 10-mile segment of river that there would have been really no way to do it any other way due to the terrain and cliffs and obstructions and things that were out there. But we obtained an emergency authorization in that case because it was disaster response, and were able to capture the entire 10-mile stretch, captured it on Saturday, processed it overnight, delivered it on Sunday. So that story's in the ArcUser article as well on page 18, spring of 2016. Oh, love this one. Everyone always asks, how much do professional grade drones cost? Well, the systems that we use, just round numbers, the fixed wing systems between $55,000 and $60,000, including the ground control station. The pro rotors that we use, they're a little less expensive. They're in the $15,000 to maybe $30,000 category. So, but they don't fly as long. So 20 to 25 minutes of flying with the rotor, an hour to an hour and a half of flying with the fixed wing. And actually, we decided a long time ago it'd be nice to have both tools in the toolbox, because you don't want to necessarily go risk that more expensive fixed wing on a very small project that the rotor can do, or maybe you're capturing a refinery or a tank farm or something there where you can't get on the neighboring property and fly over it. So you have to stay within the boundaries of the property. That's where the rotor comes in handy, because they can be pre-programmed and controlled to stay within the property boundary without any problem. Okay, let's try another question. Going to how do you derive the elevation data? Comes from Chris. How we derive the elevation data, actually, the elevation data is derived from a photogrammetric process. Just if you ever took geography or aerial photography class back in college and you lay two photos down on the table that were taken in sequence, you can put a stereoscope on top and view it in 3D. That's photogrammetry. Some folks have got the right gene that can curl their tongue the right way and cross their eyes and do it without the stereoscope. I was lucky enough to have that ability, or those genes anyway, in college. But anyway, that's looking at a couple of photos at a time. And the way our elevation is derived, imagine that same thing, only instead of 2 photos, it's 2,000 photos. And the software is doing the work. So the software actually compares known points in all these various images with all the overlap. That's why the overlap's important. And then produces the elevation model based upon the imagery. It produces a point cloud, which is the same kind of a point cloud that LiDAR would produce, only instead of using a laser to scan the ground, we're using visuals, we're using the imagery. And because of all the overlap, we can produce a very, very high quality point cloud, you know, where the LiDAR may have had, say, 4 to 6 points per meter taken from the air. So you have 4 points in a square meter. We're getting anywhere from 40 to 4,000 points per meter. So it's a lot higher resolution point cloud than what you would get with LiDAR. You do have to remove the vegetation and the structures, just like you do with LiDAR. And there is some interpolation that goes on, just like with LiDAR. But the photogrammetric point cloud and DEM is actually a very good one. Okay. Another question from Christy. How does the cost vary by resolution of the data? We actually do not have any difference in price depending on the resolution of the data. What we have to do is we have to kind of do the math on how high can we fly or how low do we need to fly to capture a given resolution. But we haven't run into anyone yet who's unhappy with 1-inch resolution, and the times we're able to deliver 1/2 inch, they're not unhappy with that either. But the file sizes can get kind of large. Sometimes you know, having a compressed GeoTIFF is the way to go. Or you could take it into something like Mr. Sid or whatever to reduce the impact. But once you bring them up the first time in ArcMap, you know how it asks, do you want to create pyramid layers? If you just say yes and allow it to take that mosaic in and digest it and create the pyramid layers, then from then on, it displays very, very fast. So the file size doesn't really hurt you. That first time, you do have to let it build the pyramid layers, though. And the same applies for ArcGIS Online. It'll create the tiles in a tile package so that a user viewing it on ArcGIS Online or through a web map, it looks very snappy, very quick. Okay, here's one from Eddie. What is your initial setup cost? Include drone, camera, computer, etc.? Well, we kind of covered that one already. The fixed wings around 50 to 55,000 with the ground station and everything. The rotors 15 to 35 or so is how much they're costing. Okay. Here's a question, Steve Sherrill. Will this video be available to show to others at our office later? Yeah, Steve. As a matter of fact, we are recording the webinar, and we will get it processed and posted on our website. So, and we'll probably also drop a hint out there on Facebook and Twitter when it's ready. But we will be posting this so you can share it with others in your office or your customers or what have you. So good question. Thanks for that one. And let's see, we'll take one more here. Can you explain how you use drone to map? Was it just to produce the LIAS or other 3D aspects? Drone to map, as you're probably familiar with it, if you're not, it's Esri's photogrammetry processing solution. It is a standalone product. It's not like an extension that runs on top of ArcGIS, but it provides the options for a lot of different outputs. One is the digital ortho image, so that mosaic, the base map, was created that way. It does also produce the LIAS point cloud and the digital terrain model, which you generate the contours off of. So it actually does all of those things, and then at the very end of all the processing, if you want to, you can choose the option to upgrade or upload rather to ArcGIS Online your project and then make it available to others in your organization. So that's a pretty cool feature that they've tagged onto the end there. And then there's another whole module of drone to map that is an inspection module. It's completely different from mapping. Inspection, say you're looking at a cell phone tower, you go up and you fly a couple of circles around looking at it obliquely and then process into an inspection project. And that's different from mapping, but drone to map does that also. Okay, so I guess what I want to do at this point is go ahead and thank you for your questions and thank you for attending. Happy Halloween, everyone. And we will be posting the recording of this presentation on the website as soon as it's processed. But thanks again for attending and have a happy Halloween.